Put a couple videos together, linked together, edited into one video. Kind of got bored working on my electric CRX today. Have to pick up a connector. I need something like this so I can actually enclose the brain board inside the top of the inverter housing here, and the Arduino and whatnot, the power supply, and then have one nice plug coming attached to it. I'm going to try and pick that up in Victoria tomorrow, and then basically got all my high voltage wires routed and 2 new contactors. Everything is, this is a 175 amp Anderson. It's actually running dual wires, joining the top half and the bottom half of the pack together. That's actually a safety disconnect just to make working on it a little safer. So it's a battery in half, and means the whole system's at least somewhat possibly isolated, so you don't, if you grab any wire, you shouldn't actually be connected to anything. Nonetheless, figured I'd work on this charger for a little while today. I took one of the driver boards out of the CRX from my old one. These are one of my old driver boards out of the CRX. Luckily this one still works. I'm just trying to drive one side. I'm driving a 600 amp IGBT. I don't need that IGBT. I'm just driving it because it's convenient. I have a driver board already built for it. And in the next step, I've already gone through a few steps here. I'm re-hooking up this mess of things here. I'm going to slowly clean up as I work as well. I'm going to hook up the mess of things here, which is actually the basic concept for the charger. This is the inductor on the input capacitor, the transformer, and then the output capacitor, a couple simple little diodes. This is like, I'm expecting to flow an amp through it. I'm not expecting to flow much. So I know this whole system is totally going to be inefficient with this big IGBT, but nonetheless, it will prove the concept, and that's all I'm hoping to do at this point. And then I'll replace these components next with bigger, more badass stuff. Then we'll up the voltage, keep trying just to prove it works, and then we'll redesign the whole thing on a properly designed board, and we'll build it. So right now I've got an Arduino right here with a little do-it-yourself playing shield on top of it, little pot set up. This Arduino, actually, I found a really neat chunk of code. You can include a PWM's library with Arduino, and it allows you to set any PWM frequency you like just by simply entering in that number at the start of the code. So that was super cool. I discovered that a couple nights ago. Worked on it till 2 in the morning. So you can see it's, poke it in there a bit. There, you can see it's got the negative turn off on the IGBT. It's got about 12 volts to the system. It's actually 15 volts. Once it goes through the isolated power supply, it's 15 volts on, 5 off. So as I turn this knob, it starts my PWM, and you can see this knob actually adjusts the actual duty cycle. So I can go to 100% duty cycle, and then I can bring it back down all the way to 0. So I made a simple little chunk of code to do exactly what I'm doing right now. So now the next step is to hook up the emitter and collector, the emitter and collector to the wire that has to pulse for this charger concept, we'll call it. And from there, I'm going to flow some current through it. I should be able to hook the power from that up to the second side of my Lambda power supply. And we should be able to hook up to maybe a little light bulb or something, and then I'll watch the current flowing through it. I'll put this together in a minute. Here's test number 2. As I already said, I kind of got a little bit of a do-it-yourself charger setup going here. Just going to hook my oscilloscope probe back up. I forgot to do that before starting the video. And then from there, what we're going to see, hopefully, is as I turn up the duty cycle on my Arduino, which sends a 30 kilohertz PWM into my, it's a old Leaf driver board for my electric CRX, as seen right there. I have a bunch of new versions. This is probably version 2, and the version 3 is in there, and version 4 is under the bench to be done. That's how it goes. You always discover ways of doing things better. As you can see in this one, I didn't get the layout for the 3-watt isolated power supply is perfect. So now, nonetheless, I should be able to turn this power supply on. I now see 0 volts on my voltmeter. I have about 5 volts on the output, which is actually hooked to the charger stage, we'll call it. That's set up. The PWM is going to be between emitter collector on the IGBT. That's a 600 amp 1200 volt IGBT. It's overkill for this setup. I'm just using it because I have the driver and everything convenient, ready to go. This driver even has DSAT detection built into it. Power in my Arduino from my oscilloscope, kind of just handy. So nonetheless, you see the negative supply, so I'm going to start doing the PWM as soon as we see some. Whoa, actually I'm producing way more voltage than I thought I would be. That was interesting. Let's turn it on again here. Yeah, look at that. That is super cool. It's working amazing. Okay, so everything, the reason it's doing this right now, I'm running a very low duty cycle, you can see there. The reason it's taking 5 volts is it's a 1-to-1 ratio transformer, but it's working as a buck converter, and there's no load on the output other than, oh, and I have to be careful, I think that's only a 12 volt cap on the output. I could probably pop that right now if I wanted. Maybe we'll try that. Anyways, right now I'm just putting it through there, and it's looking like it's working super efficiently because just guessing, like I got just a little resistor as a pull down. I can't remember if it's 1,000 ohms or whatever, but it's barely pulling any current, and this is not supposed to be an efficient setup right now. It's working just basically off that IGBT, which has like a 1 or 2 volt drop as well. So let's just turn the duty cycle up a bit. Look at that, I can inch up on it. Right up there. There's 12 something volts. Barely even increase the duty cycle. Still only using like 0.05 amps. And not doing anything, not putting a load to it or anything. So I think what I'm going to do now is set up a battery. I'm just trying to think. I could possibly use this to charge a 4S LiPo battery, I think. Even that 12 volt battery sitting on the bench there, might do that. That might be pretty easy. And I'm not expecting to do much, I just want to prove that it works. But right now I'm pretty much proving that it works. I wonder, I really wished I could see the volt rating on that cap. Oh no, it's a 160 volt cap. We can crank it up. Let's see how far it goes at full duty cycle. Oh wow. So 53 volts. Like, we're producing amazing voltage. It's pulling a bit of current now, but look at the voltage it's producing, and the duty cycle's up there. I think what happens, I'm gonna go out on a limb here, but once we go full on, we're gonna drop voltage just like that. And it's, yeah, you can see it actually basically just peg the current on the output, because once it gets, we'll just keep watching that, you get to that sweet spot there where it climbs and it becomes no longer efficient and it drops off. Gotta turn the duty cycle down and it comes back up. That's unloaded, so I want to see what it can do loaded. So that's definitely something a guy has to design into the circuit, is just output voltage sensing and have it basically turn down the duty cycle when it gets to a certain output voltage. So right now I'm running like next to nothing. It's probably not even turning the IGBT on. We'll get it to where it like just starts right there. So you can see how small of a PWM that is, or duty cycle. It's running 30 kilohertz as well, like I said. So I think what I'm going to do next, like I said, is hook up a battery to this and see what kind of charge we can give that. With a 12 volt Harley battery, just one I grabbed from a dead pile of batteries and came out of an old bike. I use it kicking around the shop for tests like this. Actually got everything set up for my simple charger. This is just to prove the concept. I got to actually, eventually the input will, instead of being DC input, we'll actually be able to work off a 220 AC. That's the goal, and possibly 110. This stupid voltmeter, I hate that automatic timeout thing. Nonetheless, the one of the goals is to run 110 volts and be able to charge around 230 volts DC output. So charging at 5 volts, I actually just proved in a previous video I could turn that 5 volts into over 60 by running the sweet spot in the duty cycle, which cranked up quite a bit. So let's give this a try. We'll get the PWM started here. You can see a bit on the duty cycle. We're not producing any amperage yet. I'm going to crank it up, keep Keep coming, try and get out of the light there. Wait till we see a bit of amperage there on the output. There we go, we got a little bit happening. 0.1 amps. We're at probably just over 50% duty cycle. I wonder if I can do this. I hate this. There we go. Oops. What kind of duty cycle is that? It's close to 50% anyway. Yeah, it's close to 50%. A little over actually, but this thing times out pretty commonly. But we're putting 2 amps in at 5 volts, and we're boost converting it through just a 1-to-1 ratio inductor, transformer, sorry. And we're getting 1 amp out at 12.26. So it's like, quickly doing the math in my head, that's pretty efficient. I'm going to bump up the duty cycle a bit, see what we can do to get that cranked up. You can see it's charging a little more now. I got 0.2 amps. Now here's the cool part. We can probably make this thing even more efficient by bringing the duty cycle back down and bringing the input voltage up. But what I just did there was I just proved that at 5 volts DC input, we can get enough output that we can charge a 12 volt battery. So that means when I'm doing 220 AC input, I should be able to get somewhere around, or sorry, 110 AC input. I should be able to possibly get enough that I can charge at 230 volts output. That's what my goal is for this. I want to be able to charge half my battery pack on my CRX. So now, bringing the boot, I'm going to turn this back down like I said, and then I want to bump the voltage here. Bump it up to like 10. Get that up there, maybe a little over. Just kind of, now all of a sudden we got big amperage. It actually looks like it's a little less efficient, 0.4 amps and then almost 0.8 amps. And we're about around 12 volts input as well. So, but I'm going to turn the duty cycle up, get that to the last little bit. Right at the 1 amp mark there on my lambda. I don't want to max the lambda out, but yeah, half an amp on output charging. So it seems like it's actually a little less efficient to have higher input voltage, which is kind of weird. I want to think about that for a bit, but bring this back down somewhere around, say, 7 volts input. Then we're going to crank up the duty cycle, and somewhere around there, sorry, try and watch all the gauges at once. Oh, it's pretty sensitive to duty cycle adjustments there. So now we're charging at 0.3 amps, 7 input. Seems to be a little more efficient to have a lower input voltage, which is going to make me have to think about it and do some tests. By the way, yeah, this side is actually the output voltage for this inductor. I don't even feel any heat out of that. I just thought I did, but my hands are frozen. That inductor, nothing really. This side is actually just powering the isolated power supplies to give the gate drive on this IGBT some energy. The IGBT, by the way, is like at quite a few amps, 600 amps. It's got like 2 volts drop or something, 800 amps, 2 volts drop, something like that. It's a 600 amp IGBT rated for 1200 volts, so it's not really designed for what I'm trying to do here, but conveniently, it just so happens I have all this stuff laying around. This is an old board from my Leaf controller, and just so happens it's really handy for this. This has proven to be a viable thing, 0.3 amps right now, and the accuracy of this versus the accuracy of that, it's hard to say. I'm pretty sure the lambda is going to be almost bang on, if not bang on, and this thing, who knows how accurate. This is the actual output current going to the battery, so this times that is the actual wattage on the output, and that voltage times that is that wattage on the input to the charger itself. I think I do feel a tiny bit of heat there, but just the smallest little bit. I don't like lukewarm, maybe 30 degrees or something. Nonetheless, let's keep playing with this. Bump that up a bit more. See if we can get 0.4 amps. It seems to really like jump up fast when I'm adjusting the dial here. I'm barely moving that a little bit, and it's jumping that up really fast. Not really getting a lot more amperage in the output, so let's turn that down again to like maybe try 5 volts input. Then let's bump it up. 5 volts and 1 amp. So it seems to be pretty efficient there because it's only putting out 2 amps and 12.5 volts. But wonder if that's more, I'm just trying to determine if running that is more efficient than running it the other way. But this is pretty awesome. I'm excited for this. The next challenge is going to be to write the code for closed loop for the Arduino to be able to monitor the amperage, make it into a constant current, constant voltage charger. That's the goal with this, and like I said, make it work off of 2 AC input. So using one IGBT won't work in that case. In fact, there's another test I want to do, I just remembered. But yeah, using you have to do either 2 IGBTs in parallel, but one is backwards to the other, and they have to be IGBTs without the anti-parallel diodes, or you have to use 2 MOSFETs that are in series to each other with the sources tied together, so they're technically facing the opposite direction. That's to get rid of the anti-parallel diodes as well, but also be able to conduct in both directions with AC. So it's going to have 2 switches on the input and then basically 2 diodes in the output. I actually wouldn't be surprised with those diodes. Now they're rated for 3 amps, they're not even getting hot. So anyways, I'm pretty excited. Little video together. Been playing with this a little bit for the last 20 minutes or whatever. Added a couple of Schottky diodes to the output. They're lower voltage drop and they're a little quicker to react, make things a little more efficient. Got everything cranked up a little bit. My input is around 12 volts and a 1 amp, so about 12 watts. And then my output is around 6.2 watts output. Nonetheless, just experimenting a bit, but I also got my thermal imaging camera here. And what I'm doing is I'm trying to run it for a little bit and then collect a bit of data to see what gets hot. And I'm pretty sure, like that's the transformer. Now the transformer is not, in fact, not one part of this whole circuit is properly selected for being a charger. Even my PWM frequency at 30 kilohertz, it should be higher. This driver board and everything is tuned for running a high amperage through that IGBT at like 600 amps and being able to switch as far as 1300 amps safely. So I could definitely lower the gate resistors, be able to switch on and off a little faster, and then bump my PWM frequency maybe even to 50 kilohertz. Unfortunately, I can't bump the PWM right now because I have to run home and grab the code off my other computer. I saved it at home. Nonetheless, just kind of checking the things that are getting hot. And transformer's got some heat to it, but nothing that would burn your hand, like 42 degrees or whatever, 43. And then the bottom of the IGBT, it's a little tricky to read there, but the bottom of the IGBT, if we put the spot on it, is somewhere around 30 degrees, like lukewarm. The hot spot you see there is actually the gate resistors. We're just going to hover over top like this, try and get there, and you can actually see the gate resistors in there. They're quite hot. They don't want to be 100 and whatever degrees. They don't want to be PWMing at 30 kilohertz. This was not designed to run 30 kilohertz, but I'm kind of cheating to just make my charger prove the concept of this charger, and that's about all we wanted to do today. So what I'm going to do next is probably try and select some parts that are correct for all of this, and build the AC design and then test it on DC first and then test it on AC after, because one of my fears is I have to figure out how this charger design shuts off when AC voltage is present, because I don't want it to just continuously charge all the time. I want it to actually shut off when the battery's full. When your battery climbs up to, I'm going to charge at about 230 volts per side, roughly 233 or something, and that'll give me, with 112 cells, that gives me around 4.17 volts per cell, something like that. What I need to do is probably build one charger to charge the whole thing, or two chargers to charge separately. I'm kind of contemplating doing one charger that pumps out 460 volts at max. I got to do some experimenting to see how how efficient this will all be. I'm pretty sure a 1-to-1 inductor can do what I want for either voltage. You can just change the duty cycle a little bit and make sure your capacitors on the output are rated for it, and away you go. So I already proved earlier I can actually charge, like right now I can turn this down, get those numbers so I can remember, look at the video and work the math again one more time later, but I can turn this down to 5 volts on the input, and then you can see I got a 0.2 charger circuit itself is 5 volts on the input at 0.2 amps, and it's still producing 0.024 amps at 12.7-ish volts. The battery's a lead acid battery, so it's slowly going to fall back down. But I can just bump up, increase the duty cycle a bit, get my amperage back up there, and now I have charging happening again. So from 5 volts, I'm charging a 12-volt lead acid battery with a 1-to-1 inductor. So it's pretty cool. This is pretty versatile. It'll be pretty easy to sense the input voltage. I'll be able to have it sense if it's 110 volts input AC, or even for that matter, hook up to like my wife's Zero bike, drain her batteries to charge mine, and leave her sitting in the ditch, and I'll drive away because my bike will be charged. Anyways, should all work good. We'll keep going with this. I gotta order some proper parts and figure out how to build a proper isolated transformer. One of the tricks is there's actually 2 tricks. First off, the input inductor can actually be wrapped, the inductor loops can be wrapped in the same transformer. And all my research I've found is a, I think you call it a toroid, that has a spinning winding, kind of like a tape measure roll. That's the best way to go. I'm going to stop the video.